To add effects on moving geometry, I'm gonna to use Craig from Side Effects. Is moving, yeah. If I'm right, he's packed. I'm gonna to unpack him. I'm using a unpack node. And now what I would like to do is to add some effects on his horn here. For that, I will use an attribute paint node. Attribute paint. I'm gonna change in the attribute name. By default, it's mask. I'm gonna to use scatter source, scatter underscore source. And now I'm just paint the horns. I'm using a scatter node. For total count, I will use only 10 points for now. I'm going to use scatter source, our attribute. To have a better sight, I'm going to use a copy to point and some sphere on it. Copy to point, scatter is in second input, and in first input, I will add a sphere. I will change the uniform scale to 0.1, and I'm adding some color. I use an attribute randomize. By default, it's on CD. Yes. Now I'm selecting Unpack node. With the cursor over it, I press W, and it will appear a super template. It's not the only template if I select by clicking on this flag, but if I press W, I have the geometry, not only the wireframe. And if I'm moving on the timeline, now all spheres are moving with the geometry. But for now, we have a non-deforming geometry. We have the same topology. We don't have a deforming topology. We have only geometry moving with the animation. And in second time, we have this little clock, this icon. It means each frame, Houdini will compute again and calculate again every node who have this green icon. So it could be a loss of performances. So if you have a time dependency node, here there are many time dependency nodes, you can lose many performances. The first approach, we will use a point deform. First, I'm going to add a time shift. We will freeze our geometry. On the frame, I can right click and delete channels, or just Ctrl Shift left mouse button. And I use only first frame. Now I get my attribute paint and all this stuff. All this stuff, I said. And I plug it in a time shift. So I have my paint, my scatter, it's okay, and my point. And if I'm moving, nothing is moving. Good. And here, we don't have this clock anymore. It's not time dependent. Now we need to move this sphere with our geometry, with Craig. I press W. And I will use a point deform. From copy to point, I add a point deform. The first input is the geometry I would like to deform. Here, this is a sphere. In the second input, point lattice, this is the rest point lattice, this is a time shift. This is where the geometry is static. And finally, the moving geometry. This is unpack, just before the time shift. And now, we have our points moving with Craig. Now we see we have no deformation, our spheres are great, but if we have a deforming geometry, a deforming topology, not only moving geometry, we will get some troubleshooting, we will get some issue. I'll show you now. I add a transform. I'm gonna select just one face, one primitive. I will select this one. I'm gonna to frame one. I press enter. If I press M, I change the gizmo orientation. So I just push it. I add a keyframe on Y. I move to frame 24, I add a keyframe, and I move up a little bit. And now, if I'm looking at the sphere, oh sorry, I have the template on Unpack displayed. I need a display template on transform. I press W to display the super template on transform. If we are looking at the pink sphere, it's deformed. I add atmosphere to be clear. And if I'm moving, this sphere is deformed. It's deformed because we have a moving topology, not only animation. And it can cause an issue when you want to add some FX, or some FX we couldn't do some FX because we have this moving topology on sphere. To get rid of this, we can, in copy to point, add a pack instance. And using pack instance, there is no problem because the sphere are packed, but sometimes it couldn't work with our FX. There is another solution we'll see in few minutes. And why, if you are not packed, we have this deformation? It's because the copy to point is looking for neighbor. Is looking in a 3D sphere around him for each point, which is the nearest point in a 3D space, not in 2D space. At the first frame, this point is looking to this neighbor, and this neighbor is this one on the top, is this one, so it tries to make a blend between the point on the top and this space on the first frame. At this place it's okay, and you say, okay, I have this point is closest to me, to this side, and when it go up, it's trying to make a blend, because it's looking for in 3D space. Now the second solution is the attribute interpolate. And the attribute interpolate will not look at this neighbor in 3D space, but it's just looking is primitive number, and this UV on this primitive number. I add an attribute interpolate. I don't need this anymore. Destination geometry, so we don't want our sphere for now, but just the scatter for the beginning. Destination geometry, so this is the scatter we want to follow the geometry. And the second, it's our geometry. And if I click on the flag, I get an error because we need two attributes, source prim and source prim UV. The scatter node can do this for us. In output attribute, in the scatter node, we have these two attributes we can check. And what are these attributes? As I will just, the clipping is not enough. If I display number, so the attribute source prime is looking for the primitive, the number of this primitive where the point is. If the point is on this primitive number, it will store this number, and in addition of that, it will look at this UV, this position in 2D space, Y and X, as the same as UV, but it's for this primitive only, for this face. And if I look at the name, we get a W2. The W, it's only for a line. If you have a line, I will select just a line, a primitive line, just this one. You have ici two numbers. At this point, it's 0. At this point, it's 1. Or maybe the inverse, but it's the way it works. Source prim, the W, it's for a line. And now with this information, you can stay at this primitive, and it will not looking for a neighbor in 3D space. You will not get a point here to blend between two points in space in 3D space. I just need to select source prim. I accidentally change source prim UV to source primes. And we can add our copy to point here for now. And we see all spheres are moving with Craig, and they are not deforming anymore. And we don't need to pack an instance in copy to point. To resume, the point deform we use a sphere, a 3D sphere, to find nameboard, and the attribute interpolate just will use this primitive where he is. If he's on this one, he will use this one, and he will use the UV, the coordinate, on this primitive to move with the object. That's all. It was the point deform and the attribute interpolate.